Hey everyone, welcome. This is going to be our second to last trig video. This is going to be on actually inverse trig, okay? And once again, I'm just going to kind of get to the point. We have some review on the front, just reviewing sine, cosine, tangent, and some other things just to get it fresh back in your brain again, get you a little bit more practice. We're going to go ahead and skip to this page, all right? This is going to be something new for today. And it's answering this question: could we use trig to find angle measures somehow? Okay, because this says find the value of theta. All right, that's the Greek letter theta. It represents the angle. And so this is a little bit different than what we were doing before. We're not actually going to use trig to find side lengths. We're going to use it to find angles. And in order to do that, we need to set this up. So we're still going to write our trig ratio, all right? And if you look here, what do we have? We have opposite and we have hypotenuse, all right? So, okay, that's sine. So we're going to have the sine of theta equals 34 over 60, okay? So how do we solve this, all right? Well, we're going to have to use a new tool that we have not used yet, all right? If your variable is inside of the trig function, okay, you have to get it out of the trig function, all right? And the way that you do that is with what's called, I'm actually going to move this over a little bit more. It's called inverse trig, okay? So it's going to be kind of weird, but just let me write it out and I'll show you. Okay, so it's kind of like when you have think about when you have a square root of x. To cancel that out, you have to square it, and then you can cancel out both, and then you just get x. It's kind of like that, except sine, this is called inverse sine when you put that -1 right there. It's kind of like an exponent of -1, right? Inverse sine cancels out with sine. So this cancels out, that cancels out, and then you're left with theta by itself. And so theta equals the inverse sine of 34 over 60. And you can actually type that into your calculator just like you type in anything else. Why is it doing that? So we can pull up Desmos. I'm going to show you how to do it on Desmos. So when you click your functions to go to sine, I don't know if you ever noticed, the sine to the -1 is right next to it. I'm holding it down right now. And that brings up sine of -1. Then you just type in 34 divided by 60. Now, I'm getting a weird number. I'm getting like 0.60. Remember, we have to be in degrees, not radians, so always remember to do that. 34.5. So theta is about 34.5 degrees. Okay, and so this is a way that you can find side lengths. All right. And so we're going to do a couple more questions. This one says, solve for the missing side and angles in the triangle below, round lengths to the nearest tenth and angles to the nearest whole degree. So there's two things here. Number one, we need to find the side length x. We can do that with the Pythagorean theorem. All right, we have 13 squared plus x squared equals 17 squared. Actually, I should put that up here. And you guys should be able to do this. You shouldn't need me to walk you through the Pythagorean theorem, but whatever. So 169 plus x squared. I believe this is 289. No, 334. No, I was right the first time. 289. All right. So subtract that. That's x squared equals 120. What is the square root of 120? It should be like 10.9. Yeah, 10.95. Okay, so that was easy. And then we want to find angles A and C. So this is where, we're going to kind of have to use our inverse trig. So I don't want to use the 10.95 because that's rounded. I want to use the 13 and the 17. So if I'm looking at A, this is opposite, right? This is hypotenuse, which means this is adjacent. So for A, I want to use adjacent over hypotenuse, and that's actually cosine. Whew. Sorry. So we've got a cosine of A equals 13 over 17. Once again, you can use the inverse trig functions for anything. All right, so cosine -1 of 13 over 17. So that's what we need to put in. So I go to my functions again, I click cosine -1, and I just put in 13 divided by 17, and that is 40.1 degrees. Now I can do C pretty much the same way, all right, except C, now this is opposite, all right, they kind of switch spots. So it's going to be sine of C equals 13 over 17. So I throw in the sine -1 to cancel that out. So we get C equals whatever sine, inverse sine of 13 over 17 is. And that's actually 49.9. Now you should know that these two should add up to 90 because we know they have to add up to 180 with the right angle. So that should always happen here. So that's pretty much how you use inverse sine, all right? So you guys have 4 questions. I want you to try these questions for your practice, all right? You're gonna do them the same way that we just did these questions right here, all right? You're going to do your inverse trig functions. And again, you can pick whichever one you want, right? If you're trying to find B, you have 3 side lengths to work with. So you can pick whichever inverse trig function you want. Down here, you're not gonna be able to do that, but it's okay. So give this a shot. If you have any questions, let me know, and have a great day.